Okay, hey guys, we're back starting a new part, and now we're going to start going through the rest of these 12 boards. I counted them. There's actually 12 boards. So we're starting in on board set 4. I've already been through board set 1, 2, and 3, and they're all okay mostly. So our goal here, we're going to run through the rest of the 9 boards, and we're just going to populate them, see what they're doing, make the note, and we'll just cycle through all of them. So this is our first one, and I think for this project, it's just if you have a lot of boards and you need to do this, the reason I'm going to run through them, check them without fixing them first is if I do truly have any parts boards that are totally scrap, I want to know right from the beginning so I can use them boards for extra parts. So just like we're going to follow up from the last couple of videos of the power setup. So you can see I've got a brand new board. I've never looked at it. And this is how you can troubleshoot your boards too if you don't have ROMs in them. So anyway, I'm fired up. I got the power supply on, and we are fired up with 12 volts, 5 volts, and I do have my negative voltage, but there's nothing happening. We don't have the processors or the software in here. So we're just going to check for power. So let's start. I'm going to follow the sheet I made. I'll put it up here. 4.97 is bouncy. I'm going to turn that up a little bit. Oop. And so I have such a fine adjustment on my power supply. All right. Oh, 5.2. I might take that. Let's go to the other side of the edge connector. See, I already dropped a millivolt. Okay, so let's start working our way, checking all those points that we talked about on the last video. We'll just start up here. These guys should have the 12 volts. That's a little low too. I'm going to turn it up unpopulated, and we'll just deal with that later. Let's get this right at 12 on the board. Wait, just a little over. Just a little bump. Bump. Oh, a little bump took me. Yeah, I have to be careful. You have to go really slow on these. All right, stop there. All right, 12 volts on our switcher chip. Now this guy, 1195, he's just a little different. Let's check him again. 96 millivolts, 96. Okay, so our 12 volts is good there. So let's just jump up here. Let's do the CPU sockets. All right, CPU, PPU, a little bit low here on the board. So let's just turn that up. So we know when we populate it, we're sitting at a good voltage. All right, let's do the ROM banks. So I'm just hitting the power pins. These will all be energized from your power bus without any chips in them. So you know when you put the chip in, good to go. You are good to go. Your chip will be happy. Let's hit some of these logic chips. Try not to short anything out. Right at 5. That's logic chip for side B. Let's do the ROMs for side B. Oh, that one I have a bad connection. Nope. 5.01. 5.01. Let's do the 2 RAMs. Let's do the RAMs while we're here. 5 volts, 5 volts, side 2 PPU, side 2 CPU. Remember the boot up ROM, the memory memory RAM. The voltage won't be the same as the others. It's going to have whatever the board is minus a diode drop. So 4.6, we can live with that. Let's hit these two. I'm going to hit these 2 filter capacitors here. I'm going to hit the other side too. I'm going to hit both sides of those just to make sure, at least there's nothing obvious with the voltage. Let's hit the big filter capacitors. 5 volts, and we should have 12 and 12. Okay, so I think this board, we're ready to populate it. And what I'm going to do, this is my golden set. This is why I've been working a little bit off camera. So these 2 sets are perfectly fine. I've tested them over and over and over. It's side 1, side 2. So we have Super Mario in side 1 and Excite Bike in side 2. And we'll just run every board with the same software until they break. So, all right, we're going to cut here. We're going to get it populated, then we're going to turn this thing on. Okay, so we're back on that board, and we have dead picture, but I want to show you something. I think I'm onto something, or at least one problem. So right now, I'm going to zoom up here on this circuit right here. Let's zoom in here a little bit. Perfect, right there. So the CPU and the PPU are not resetting. It's reset stuck low. So we're looking at the reset circuit here at 1J. It's at LS123. So the Q13 of this latch is a dual latch. This guy right here, 2K. Then we have a hex inverter is stuck. 5K we're getting a pulse, or 2K pin 5 we're getting a pulse. 6 it's stuck. So I'm going to show you guys. I got it here. So let's just go on that chip. 1, 2, 3, 4, 5. Okay, let's take a look at the scope. And we can see the reset circuit there if I get on the pin well enough. Alright. So we should see, I did change the setting a little, but it should be resetting, or at least, there it goes. Okay, I just wasn't on it good. So there's the reset blink going. It's going high, it's coming low. Now that's the input of that hex inverter. Now let's look at the output. Boom, it's floating. I got my 0 volts is here, so it's about 2 volts. So it's not, and it's stuck. It's not even trying to pulse. So I'm going to go over to the other side. We're going to look at some of these other gates a little bit, the ins and outs. And I'm going to show you some suspicious activity. All right, so there's input. Oop, we get on it. Okay. All right, there we go. Input, output, input. There's an input pulled low. See, that's only like, oop, get on it again. See, that's only like 2 volts on the in, and then the out is 0. So I don't know if 2 volts is high enough for it to trigger it, but it seems like maybe this chip is not performing good. So that's the next gate, 2 volts. And I looked at these circuits and they shouldn't be pulled low like that. And then the output is low. So I don't know if that whole side of this chip is bad, but we're going to change that out. I'm going to see if we get that signal back. But before we do, I wanted to film this. We're going to take this board and we're going to flip it over, and I'm going to show you what I found on the back side. So down here, I found a mod, some sort of mod to the reset circuit, which is where we're having our problems. So I've seen this one resistor. This one, it's a 1K resist, 10K resistor tied to ground, basically like a low voltage. Basically pulling it down. It's weird. It's pulling that leg down to like 3.5 volts on this latch. But it's not this one that bothers me, because we've ran those other boards with that in. It was this component, which I haven't measured it yet. I don't know if that's a resistor, but they have that from one of the clears, or the external outputs of that latch. One of the external additional outputs being pulled low. And this guy, no, you know what? I'm sorry. This one is the output for the reset. They had it pulled low. I'm sorry. I'm fixing that right now. This pin feeds all the other reset circuit, reset to the PPU, CPU, both sides, and it was pulled low. I have no idea what they're doing here. And then down here, this one, is, they have a diode jumped in that latch circuit. So we're getting a really weird, oscillation with that in. So I took that out, and it could be, there were several service bulletin mods. This could have been the memory, for the memory access, which doesn't make any sense. This is in the reset circuit, so I don't know what they were trying to do, if there's a flaw in this, but we're going to find out. So what we're going to do, I disconnected that, and then that freed up, and then that actually freed up this pin 5, so we could actually see what our reset was doing without it being pulled low. So very odd indeed. So long story short, this 04, I'm going to replace it. We're going to put a new one there, and then look at that reset signal. And then we'll deal with that mod. We'll just keep peeling that back. Okay, be back in a minute. Okay, so I've got that 04 out of the board into the retro chip tester, and let's give it a go. Oh, it passes. Oh wait, no, this is the this is the one I'm going to replace it with, actually. So that one's going to go in the board. This guy is the one that we pulled out of the board. So let's get him in here, in blind in the dark. Oh, there's some light. It's a miracle. All right, there we go. And let's test it. Look at that. Bad. I had a feeling that guy might be bad. Okay, so let's get this new chip back into the board. That's a good one. So I got the socket in. Let's just check that guy out before we stuff him in there. So some of these 04s spec'd out on this board are fast speed, and I don't think this is one of them. Here we go with the dual wipe thing. That guy is nice and tight. Feels like something's bending already. And it's dark in here. There we go. Ooh. All right, so let's do a power on and see what we got. And we still have a dead board. Oh, but something's happening with the audio. Got some weird audio going. All right, we're gonna probe that gate out. So let's look at that gate that was. Oh yeah, she's got audio output. Okay. Oh. So let's go. I think the reset might be gone. 1, 2, 3, 4, 5. Now our resets. It's not resetting now. And that's the output. Reset low. So reset is still low to the CPU and PPU, but at least it's kind of solid. Let's look at the rest of that mod. Now maybe we can see what's happening with that mod now that the reset circuit is measuring good. Okay, before I get too far away from that reset, I just wanted to show, before we move on, the game, now the board is actually booting, at least side 2. Side 2 is booting. Super Mario is actually running. This is messed up, and then we have dead side 1. So on that reset circuit, that I see that 04 I changed was definitely bad. I'm going to show you the input. So I replaced this 04. The inverter gate was stuck. So let's look at that on the scope now. So there's our reset now. So our reset's high and the game is booting. So there's the in and there's the out. And I'm going to manually ground it just to show you. Actually, let's just reboot it and I'll show you. I'm going to power cycle it, the 5 volt. Oop, I guess I have to probe it on the way on. Okay, here we go. Power on. Low, high. So that should be enough to reset the CPU and the PPU. So I'm fairly certain that's good. So now moving on, we have obviously still have problems. So I've been probing around. I'm going to give you the lowdown, what's going on here. So this is side one. This is the side that's not booting at all. And pretty much what's happening, the CPU, what are we missing here? We're missing all the data. The data lines are not working here. We have a 245 here. That's part of the boot up process. So he's like a bidirectional bus controller. So he's not getting enabled at all. So he kind of enables the RAM at 1C, and these guys are pretty much dead. So none of the ROMs can run. So, but this guy, the 5533, he has full data activity. So I don't know. So my suspicions are track down the direction control for these, but those come from the CPU, and I'm not quite sure that's the problem. I think if the CPU is running, this would get the direction control, and that would engage. What other things are not working? 1F, this guy right here, this 138 selector, he's not working. So he cannot address. He's the chip selects for the bank of ROMs here. So I think there's just something not engaging and working. And I'm looking at. I'm going to show you the circuit. I'm going to show you now on the blueprint here. And then I'll tell you what we're going to do. So basically, let's see if we can. Yeah, like the sun coming in, nice and sunny here in Thailand. So basically we have CPU and PPU here. Yeah, there we go. CPU and PPU. What's not working? This data, there's no activity here. So I think the processors can't even fully boot up yet. So I think all this other stuff not working is an effect of the CPU's not quite working yet. And I've been through all the control lines. There's a lot of missing control lines that go back, call it the boot up section, your main boot up RAM, and then your 138s, and you have some 245s down here. So these that are feeding side 2 are kind of working. This 3K is definitely, I wouldn't say he's suspect, but he's not operating, he's not getting the direction in and out here. So one of his enables is an output of this guy. He should be high, but it's low. So this guy can't do anything. This guy is dead. But I think since the mirror image side, the 245 on side B is kind of working, I think it's okay. But you go up here to what's feeding those, and we're going to come back to that. That whole area is suspect, but no, I probed all these, and no smoking guns here unless I had, I wish I like an analyzer or something. So I think given that what's going on, and I'm probably going down the wrong hole here, I am going to replay, I'm going to pull these two, I'm pulling these two ROMs, RAMs. I'm pulling the RAM at 1F and 6F, these 6116s, and I'm going to put those in the retro chip tester and check them out. And also because I know I'm going to have RAM problems with the other 10 boards, so I wanted to get one board with sockets in it so I can also test the RAMs here. So I actually have some of these. So I'm gonna cut here. We're gonna pull these out and then kind of go from there. Then I can just rule these out that it's not able to write or read, and that's keeping this stuff from booting up. We're gonna find out. And if that's not the culprit, at least we know they're good, and then we'll move on maybe to that decoder section or look at some of those other control signals a little closer. Okay, let's get her done. Okay, we're back after taking out all the RAMs on this board and kind of checking everything out. So I went ahead and desoldered the two 6116s and the TC5533 4K by 4-bit by 8K, 4K by 8-bit RAMs, and then I also got this guy up here, the 8416. So I went ahead and desoldered all those, took them out because I don't have a fluke or anything, and I ran them through the retro chip tester here. So what I found was maybe kind of what I thought. These TC5533s, both of these fail. And I also pulled out that other LS04 chip. Yeah, I profiled him. He looked like his buddy that was bad. So I just pulled him, and guess what? He was bad too. So I got another bad chip out of the board and these two bad RAMs. So these, the Nintendo MDS parts list calls these 4K by 8 RAM, but on the retro chip tester, since the 62 64s are known replacement, I just rolled with that on the chip tester. So I'm gonna show you. We're gonna run those tests here. Let's see. All right, so we're set up. I was checking the different RAMs, so let's go back to the 64, and I wasn't quite sure these were going to test out okay or not, and you're going to see what's happening here. So we'll do the one, and I lost track of which side was which, but okay, so it's testing, it's writing AA, and right here on AA, it's not equal with what it's reading. It's writing AA and it's reading AA, and it just fails out right there. And then let's run the other one. And at first I thought it could be a different in the pinouts, and the test might not pass because pin 6 on this chip is a little bit different than the pin 6 on the 64. Oops. So this one's not hardly even reading. You have to get him in just right. Okay, so he's writing 0, testing 0, writing 55, writing AA. This is where the other test fails out. So the fact that this chip goes further in the test than the other one, they're not failing at the same point, so I have confidence that this program. Okay, so here's what we get on this guy. We get a during the count cycle, I think it's counting, we have something bad going on at cell 16F0. I don't know if that's a not equal to, I forget, but it's failing. So let's actually I got my board powered on. I'm gonna grab one of these other 64s. I'm going to grab one of these other 64s and show you how they pass. So let's just zoom out a little. We're just going to slide this guy in here and pop him out. We're going to pop this one. And we're going to look and see what that whole test looks like. Okay, there we go. And we're going again. Same deal. Writing and reading the values. So this is exactly where the other one failed, right there at AA. So now it's continuing. This chip is testing better. So it's funny that when the circuits were all dead, these are the only ones that looked to be operational. They had data and addressing going, and could very well cause the black screen and the other side to boot to garbage or play in garbage. So okay, we're gonna pop him back in here. We're gonna pop him back in. Okay, so now we're gonna power on. We're gonna power on. I'm gonna show you guys what we have. Boom. Get that out of the way. And look at that. Changed out the RAMs. And now we have both sides good. But I've been mucking around a little bit. But we got problems up on side 1 still. Look, there's garbage. We have problems on side 1 still. And once it runs a little bit further, it's going to freeze. So we're just going to kind of watch it until it freezes. And then we'll move on, at least for this checkpoint. And right here, the game is froze. So, oh, made a liar out of me. It's the first time. It's the first time it actually played. It was freezing there every time. Wow. Oh, there it goes. Boom. He didn't make it too far. The dude is still running. Look, he's running to his bike. And yeah, we have a problem. We have a problem. And you can't tell. Okay, there. Well, see, when I zoom out, it's all garbage. So there's like 2 screens flashing. There's like, it's writing like, it's switching between the current and like a future or past frame. Like you can't see it because that looks like one single frame. Let me back out. But that's actually what it looks like. That is so bizarre. Okay, so at the bottom, let's go to Mario. Then let's go to side B. And side B is missing red. That's about all I know. Okay, we're back after taking out all the RAMs on this board and kind of checking everything out. So I went ahead and desoldered the two 6116s and the TC5533 4K by 4-bit by 8K, 4K by 8-bit RAMs. And then I also got this guy up here, the 8416. So I went ahead and desoldered all those, took them out because I don't have a fluke or anything, and I ran them through the retro chip tester here. So what I found was maybe kind of what I thought. These TC5533s, both of these fail. And I also pulled out that other LS04 chip. Yeah, I profiled him. He looked like his buddy that was bad. So I just pulled him, and guess what? He was bad too. So I got another bad chip out of the board and these 2 bad RAMs. So these, the Nintendo MDS parts list calls these 4K by 8 RAM. But on the retro chip tester, since the 6264s are known replacement, I just rolled with that on the chip tester. So I'm gonna show you. We're gonna run those tests here. Let's see. All right, so we're set up. I was checking the different RAMs. So let's go back to the 64. And I wasn't quite sure these were gonna test out okay or not. And you're gonna see what's happening here. So we'll do the 1. And I lost track of which side was which. But, okay, so it's testing. It's writing AA. And right here on AA, it's not equal. With what it's reading, it's writing AA and it's reading AA. And it just fails out right there. And then let's run the other one. And at first I thought it could be a different in the pinouts. And the test might not pass because pin 6 on this chip is a little bit different than the pin 6 on the 64. Oops. So this one's not hardly even reading. You have to get him in just right. Okay, so he's writing 0, testing 0, writing 55. Writing AA. This is where the other test fails out. So the fact that this chip goes further in the test than the other one, they're not failing at the same point. So I have confidence that this program. Okay, so here's what we get on this guy. We get a during the count cycle. I think it's counting. We have something bad going on at cell 16F0. I don't know if that's a not equal to, I forget, but it's failing. So let's, actually I got my board powered on. I'm going to grab one of these other 64s. I'm going to grab one of these other 64s and show you how they pass. So let's just zoom out a little. We're just going to slide this guy in here and pop him out. We're going to pop this one. And we're going to look and see what that whole test looks like. Okay, there we go. And we're going again. Same deal. Writing and reading the values. So this is exactly where the other one failed, right there at AA. So now it's continuing. This chip is testing better. So it's funny that when the circuits were all dead, these are the only ones that looked to be operational. They had data and addressing going, and could very well cause the black screen and the other side to boot to garbage or play in garbage. So okay, we're gonna pop him back in here. We're gonna pop him back in. Okay, so now we're gonna power on. We're gonna power on. I'm gonna show you guys what we have. Boom. Get that out of the way. And look at that. Changed out the RAMs. And now we have both sides good. I've been mucking around a little bit, but we got problems up on side one still. Look, there's garbage. We have problems on side one still. And once it runs a little bit further, it's going to freeze. So we're just going to kind of watch it until it freezes, and then we'll move on, at least for this checkpoint. And right here, the game is froze. So, oh, made a liar out of me. It's the first time. It's the first time it actually played. It was freezing there every time. Wow. Oh, there it goes. Boom. He didn't make it too far. The dude is still running. Look, he's running to his bike. And yeah, we have a problem. We have a problem. And you can't tell. Okay, there. Well, see, when I zoom out, it's all garbage. So there's like two screens flashing. There's like, it's writing like, it's switching between the current and like a future or past frame. Like you can't see it because that looks like one single frame. Let me back out. But that's actually what it looks like. That is so bizarre. Okay, so at the bottom, let's go to Mario. Then let's go to side B. And side B is missing red. That's about all I know. Yeah, I think my camera died. Anyway, so what we're going to do here, just one last shot. Mario's playing without red. No big deal. Kind of fun circuit. And then up top we are freezing this. Now, after we changed the two RAMs here, now it's booting. But I think we have socket issues. I know some of these are already broke. I'm looking for them. I think one of these is chipped off on the end. And if we look, I'll try to find it. One of these sockets is cracked all the way right there. That's cracked and broken. And I think, yep, right there's another corner missing. So for baseline, we're going to see, let's reset that. So we're going back to the 04 that we changed. Now we can ground pin 6 and reset, and then Excite Bike will run. See, this is why I think we're having connection problems. Seeing the flakiness, I think it's like a power, it's a contact, low contact somewhere, that kind of shading. But anyway, what we're gonna do, we're gonna replace all these sockets. These for CPU and PPU, and the 6 for the ROM chips. We're gonna do it. We're just gonna do these 2 first, and then we're gonna see if that continues. I will create a baseline with sockets. Yeah, because even that reset, we're gonna reset that again, just for. Yeah, see, it was playing way better than that. It was playing, look, I'm pushing on the PPU and it got better. Yep, we're going to swap out those sockets. Yep, see, now we're back. Just kind of rocking the PPU. So, I got my sockets ready. Just going to cut here. We're going to come back when these 2 are changed. Here are the new sockets for the CPU and PPU, and the game is running. But unfortunately, I believe Excitebike still has a problem. But I tell you what, it's a lot cleaner. It is a lot cleaner, and it's actually some different stuff going on. Look at the shapes drawn. So this might actually be running better. So, with that being said, we're gonna just do these 6. We're gonna do these 6 ROM sockets because that whole side is broken. Got that corner is broken. So we're gonna wrap it up for tonight and then get these done in the morning, and we'll give our baseline another look here. We're back after replacing the ROM sockets, and it didn't do anything to change the game. So the game is running. It might be more clear or something, but it's definitely still going to glitch. It's going to glitch out here real soon. But anyway, the sockets did not fix that problem with the freezing and the graphic problems and stuff. So we're going to move on. We're going to put a pin in that. And we're gonna go over and take care of no red on Mario. So let's take care of that first and see if that reveals any. See, now he's froze. The bike dude is froze. Okay, so I wanted to show you. We'll bring up the video circuit schematics now, and pretty much I'm going to be probing around the red. The color section. So for the board, this is player 1 and this is player 2. Oh, gosh darn it, backwards. This is player 2. So these variable resistors, kind of like your landmark, these guys control Super Mario Brothers that's running down here with no red. So we can just start at the beginning. The red, let's just probe on red. 98765 All right, I know. Let me change my scope. You kind of see. Okay, so there's red coming right out of the PPU, and let's do red and green. So we have red coming from the PPU, but he's not making it to the screen. So let's kind of probe around. I've already been probing around, and let's have those prints up here, and then I can show you. So we come in the color signal. Let me find red, and I color coded some of the transistors to make it easier to see maybe for the video. So for the red, this is pretty much the red video circuit here. Red comes into the base of Q15. So we can see on the scope we have that same signal. So let's follow red around through the transistors. Okay, so there's the base, there's the emitter, and we have red on the emitter. So from there, red on the emitter. Okay, so from there he actually goes through this capacitor on the negative side, have a signal, and then come up to the we'll call it the output of this capacitor. Oop, I gotta change the scale so you guys can see it. Okay, sorry. And on the capacitor. So now we have like a 12 volt signal with with red, with a, call it a composite, and a red video signal. So he's there. Okay, so from there he goes. Then we go into the pair of transistors, NPN and a PNP pair here. You can see on the print there. So then we can get in here, and we have the same signal on the base of Q7. Q7. Now let's look at the emitter. We have nothing. And I believe collector is ground. I'm not actually looking at the prints. I'm just kind of going off memory here. So let's go. And that would be on the board, this transistor. This is your first one, second one, and then your final drive out to red. Now let's look at that same circuit on green. Let's see what green is doing. Make it kind of easier. So green has same circuit. Input, that's your first one, your second transistor, and your third one. So let's look at good. Okay, there's a good signal coming in on the base of that second transistor from green. Now let's look at the emitter. See, we're still holding a almost 12 volt, but we have a composite or video signal. Let's go back up to the emitter on red. So red's got nothing there, and then I believe collector might be grounded. Let's look at that. Oh no, collector actually has a waveform on it too. So there's nothing happening here on the collector. I'm going to show you. So the collector is dead too. That's the collector on red. The middle transistor. Just in case I don't get the video cut in and edited very well. So that Q7 is this middle transistor. So we have signal coming in, collector is grounded, then the emitter has a signal. So from here it kind of splits off. It pulls high into a 12 volt that comes back and feed the collector on the final drive. But before that, it comes through that capacitor into the base of Q7. So Q7 has activity, but there's nothing there's nothing here on the collector, and going. The emitter is actually okay on 7, I think. Let's look at the emitter. Let's look at the emitter again. Well, not really. He's kind of pulled high. So already there we have a problem. You know, that's what it should look like. The emitter on a good color. And this is the emitter on Q7 of that red. So I think what we're going to do, I already kind of scoped around. I've probed the audio amp, and the audio amp is different too. But if you look at the circuit, if you have nothing on the base or emitter here, no signal for that switch, then the amp's really not going to put out anything. But you can definitely see something's wrong here. I don't know. I don't think it's this amp. I kind of want to go after these two transistors just to see. And I did meter them in diode mode in circuit, and they were both okay. Like when I compared them to in diode mode, checking blue or green had the same value. So I don't know what we're going to find here. I'm thinking about changing that capacitor too, because the signal looks a little like deteriorated versus green and blue. But I don't know. I think we're going to go after these guys. Let's swap them out real quick and see what we get. Okay, so we swapped out that transistor in that red circuit, and still no red. So probing it out again, just kind of taking a look here. Here's my new one here, Q7. So going back to the scope, we have our signal coming in on the base, but we still don't have anything on the collector or the emitter. So let's look at the collector and emitter on green. So on green, the same one. There's what we should be seeing on the collector and there's what we should be seeing on the emitter, a high 12 volt, but with a pulse. So let's go back down here and look around. I think so. We changed this guy out. So basically, we have signal coming in. We don't have anything on the emitter or anything on the collector. So that variable resistor is here, and I tested it already. I think we have our swing, we have everything there. It's not shorted. It is actually adjusting what signal. So, but on the collector here, we have nothing. We have nothing on the collector, so I don't know. We'll go for this. We'll go for this Q9 next. And it tested good in circuit. So, oh yeah, that was the other thing. Out of circuit, he tested fine. So whatever, we're gonna keep pushing on, just step at a time, so we can see exactly what's going on. I think we'll do this Q9, and then we'll go back. Maybe, I don't know. I still don't think there's anything wrong with that switch, but maybe that amp could be causing us some problems, because it does. Collector here, it does come over. Let's see, the amp comes up, the output through the resistor up into the base of Q7, which is really where we don't have anything. But I still don't think if it can't get that signal through to here to the Q9, I don't think anything will happen with this amp at that point. So I don't think that switch is working, or that amp gate. Let's go for Q9 next. And yeah, we'll stick for Q9 for next. I did get some capacitors. Might swap out red capacitor because he just looks a little funny. So anyway, let's change this guy right here, Q9. Okay, so we're back, and check this out. So I socketed the 324 and the 4066 video switch IC. So Mario, we lost colors. Like, we lost some on side A and B that used those gates. But I think, it was Excitebike was actually running better. So let's pop in new chips and see what we get. Okay, we're back. So we're swapping them out one at a time. I put the new LM324 and kept the same video switch. So we still have no red. Let me try to adjust red. Let's try to adjust red. I think, yeah, nothing happening. No red, but less graphics problems on side one. Kind of weird. So let's pause here. I'm going to go ahead and throw in the new switch. Okay, we're back with Mario, and we have red, but it's not what I thought. So we have red. What did we do? So I ended up, just to recap, I worked a little bit off film. I socketed these. I thought maybe because the one signal, I thought maybe because we did not have anything on Q7 on the base or the collector. No, the emitter or collector. Yeah, we didn't have anything there, and we had some funkiness on the base even. So what did we do? So I put a new op amp, and I'm sorry I didn't film it. New op amp brought it up with red jail bars, and the frequency was really kind of bad, honestly. So there's our output, and with when I put the new op amp in, the 324 had like a really tall amplitude wave there, and you could tell like by seeing the jail bars. So I went back looking more, and I got to the capacitor here, and I should have just changed it earlier. It was my gut feeling. This capacitor here, the emitter, your main signal, your emitter comes up and it passes through that 10 microfarad 16 volt capacitor, and the signal here was kind of ugly. It was really squashed, but I thought, well, maybe, it was, I don't know. I didn't think about it. I was just thinking about not having any signal here, not having anything here. That needed to open up so it could feed that amp back around. But after I sell the jail bars, then indeed comparing this one, this capacitor in the same circuit to the other ones, was obvious that that guy was not good. So actually two things, op amp and capacitor, found them both. Okay, so that's the end of that. And let's go into trying to fix Excite Bike. See, he's froze. Let's recycle him. Recycle. Power cycle. Kind of like a motorcycle. Okay, but right there, boom, he starts glitching. He starts glitching, and then he'll freeze eventually. But, so down here we did a lot of work too. We got rid of any connection issue. We got rid of the RAM issues. These RAMs are all good. These ROMs are all good. So let me grab the probe here. I think, just kind of keep this segment short, I think I want to change out this 138 and chip select. Chip selects are kind of tough because, let's get this on the right division. Chip selects are tough because without a signal meter, DSO, you can't really analyze the signal. So these are the chip selects for the ROM banks. This is why I want to change this out, because we eliminated everything else, and it looks like the game, see, it's like not selecting the right code or something correctly. Like you can see the little motorcycle dude, it's not writing and reading and retrieving things properly. So I think this guy, he's our next closest suspect. He's the chip selects for our ROMs here. Why I'm going to go after that? Because if it's a processing problem, then we're kind of back. Then we're kind of back looking at this section here. If one of these 157s isn't addressing right or isn't selecting right, you know, it could be way back there. It could be way back in the 245s. But let's get open to that 138. I want to show you guys where it is. Yeah, just rolling along here. ROMs. Let's see. Not that guy. Where is he? The chip select. I'll have to open him up again, I think. Where is the chip select for those guys? Output enable. Let's see. This guy right here. This guy right here. Inputting with some of the addresses from over here. It's the addresses between really like your PPU and that first ROM there, or that first RAM. Those feed in. All right, where's my pointer? All right. Inputs here. See the data line. The data lines are actually called. It's their own data bus. Okay, that just kind of splits off here. Second one down. Second one down. Second one down. Feeding in here. Chip enable. Chip enable. All those guys. Let's see. So we got some, we do have some addressing coming from over here too. That's why I want to start with this guy. He's more near, and I think we're close. I think we're close to figuring him out. Let's look at those inputs. 138. Coming down here, feeding DBE low on the PPU. Just follow it, keep following him over. So down here, gonna feed these guys. Chip enable. I don't know if I'm following the right one here. Let's try it. We'll go back. Okay. Okay. Your chip selects. These are going to be... Oh, maybe I'm backwards. Maybe those are the inputs. I think... Yeah, those are the inputs. I'm so sorry. Input and output. So we're going to look at this a little bit closer. I'm going to probe around a little bit before I take it out, just to see if I see anything fishy there. But yeah, this is taking addressing right from the CPU. You have 3 bits, and the outputs here are feeding over into the chip enables. So let's give that a closer look. And plus another thing, another reason I was probing around on that. Let's look around. I was probing around on that, and it was actually glitching. Let me probe those 3 enables. Yeah, before. Oop, yep. See, when I'm probing it, it's glitching. I'm not sure that's a good enough sign to warrant pulling that out, but I'd rather. I want to start here. I want to make sure that is doing correctly. We'll check. We'll test it in the chip tester. Let's get that guy out. Okay, we're back. We're back, and as you can see, we have a running board now. And I'm sorry, I did a lot of work off camera, but this thing was like possessed, and I couldn't keep up with the filming and try to chase down everything that was happening. So I'm just going to recap from where we left off, which I think was we went. Okay, I'm going to back up here. I'm looking at my notes. It wasn't booting. It was resetting. It was weird on both sides. We pulled the sockets on one side, still acting weird, but I learned a lot on this board. So first thing, let's go in and just get this recap kind of done. MDS-02 boards are, from what I learned, very specific in things I read on Clove and tested here on the bench. So one big problem on the O2 board, you have to have Super Mario Brothers on the A side. If you have Super Mario Brothers on the B side, it's gonna reset. It's gonna not act right at all. The board will not run no matter if your ROMs are good. Okay, so I got to show you guys this. Hopefully you can see. Look at that. That was one of those 4066 chips in the video section when I was working on it. It completely blew up. It let all the smoke out. That thing, look at that. And I had socketed it, and it trashed the socket too. I have no idea. I checked my power. I think it was a bad chip. That was a replacement chip I bought. I think the chip was bad, and it trashed the socket too. So that was a good one. So went back into the video section. These 4 guys. I socketed all of them, tested all those chips, and repopulated it. So the red color, we had 3 things bad with red. Red on the B side, this red. For one, okay, I'll just count going. We had a bad LM324, we had a bad 4066 switcher, and this 10 microfarad 16 volt cap was bad. There was actually 2 of them. The blue was bad. The blue was bad for player 1, and the red was bad for player 2. So I recapped this. I recapped the whole board minus these guys. I did not recap these. Those are for controls, and you kind of know if something's weird there. But all the 3.3 microfarad 16 volts, all the 10 microfarad 16 volts, and we did this guy and the one behind here, you can't see him, the power, just a filter cap on both sides. We did all the capacitors, and just kind of, and I tested them with my meter. I got the bag. A lot of these were like not reading right, actually. A lot of these were on the ESR meter, like half, like barely 5. Some of them were almost open. Yeah, so I just replaced them all. And okay, so we dealt with red. I learned about the Super Mario Brothers. So while I was testing, go to the board of naughty chips here. My golden set of Excite Bike had a ROM actually go bad. Put this in the naughty box. I cleared them out with the UV light, and he had bits flipped that would not flip back. So he went bad during testing, which was another problem. I wasn't sure what was going on. I checked all the ROMs. Okay, so the bad, what else did we have? We had 2 bad 04s. Where are they? 2 bad 04s. These 2 were bad. And they came, let's see, crap. One was here, and one was there. What's that guy? 04 and 04, yeah. Both of these were bad. 04 was bad. So when my board was I was having problems with my board, the graphics problems, I was getting lots of graphics problems. If you have Super Mario over here, you are going to have major graphic problems. And I pulled these 157s because I didn't think it was reading and writing right. I thought maybe one of these were corrupt. And these are hard to test in circuit because all the inputs and outputs could have activity, but unless you have a logic analyzer and can see the counts, it's kind of hard to tell in circuit. So I pulled those. Probably I didn't need to, I guess. And then I also pulled this chip select here, and kind of the same thing as a 138. Kind of hard to check in circuit if all the gates are working, but it's like corrupted and it's not reading the right bits or whatever. So really didn't need to pull these or that, but I did anyway. And just recapping, we pulled all the ROMs, or all the RAMs. We pulled all the RAMs, and then I put back, because I wasn't sure the retro chip tester would test these 5533s, which are similar to this guy, but there is a pinout difference, and I think that's why I wanted to check it in circuit, because I didn't trust that the retro chip tester could check these 6264s. They could check these okay, but I think the pin 6 or address, I think it's address bit 11 or 7, are flipped. So I think I had to make a little adapter, and it will check these just fine. So I went ahead and put them both back in circuit, and only one of them was bad. The one here I have in red I just showed, that guy, he was giving corrupted graphics. You'll have the game was running, but a little bit of garbage. So I'm going to deem him as bad, and I put the good one in. I'm kind of testing him now, and then I think that's about it. And dun, 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 the pile of sockets got bigger. So I realized in the midst of all of these problems, the resetting, the bad garbage, everything else, that indeed the connections were not good, the CPU, PPU, and at least I think this socket here was not making good connection, and no good connection was making it reset. So I had a bunch of problems I was trying to work through. I had reset because the sockets were bad. I had reset because I had Mario over here, and I had corrupted graphics as well because of the game's not in the right side, and I had corrupted graphics because I had a bad ROM chip. But we worked through it, and I think we have a good working board now. Sorry I did so much work off camera, but man, we have like, what, eight or nine more boards? So I'm not going to go into depth any more on this guy. That's what we did. That's how it's working. The one thing I want to show, I don't know if it's a big deal, I did replace, when I was going after red, I did replace these two, I don't know if you can see them back here, these two red transistors. This is the final drive. and the preamp for the final drive of the red output. I changed those. I replaced them with the exact same, and I think it looks to me like red is just a little too red. And I've been over it with my O-scope. I've been over the signals, and the voltage levels are correct from side to side on red. And I tried to adjust it. I think red is a little washed out. Not washed. I think he's ultra bright. But I have the red potentiometer all the way down, and red is just, you can see, he's bright red. Bright red. So I don't know. I think I'm just going to let him ride. I think that Mario, that side A, will just have a strong red. And I was hoping to see it on the scope, but I did not see it on the scope. The voltage levels are all the same. I don't know if it's a current thing with those new transistors I put in, but we're going to let it ride. I had considered changing all those transistors, but nah. We're running good. We're looking good. We'll get those in the red tents later. I think they'll look great. And I think that's about it, guys. I'm going to power down and show you one last thing. Let's power down. Boom, boom, boom. One last thing I want to show you is about the 6116 RAM. So this, I removed it, extracted it from the board, and the legs, I'm not going to pull it out of that socket. The legs are really short. So if you pull that out, you definitely have to make a little adapter. So what I did, I took a 40 pin machine socket, and I cut it, and that seats really well in there. And then now we have a RAM with a new adapter, and that will make good contact in your new dual wipe socket. So that's the last thing I wanted to show. Another thing I did, just kind of since we have so many boards, these oh, excuse me. The CPU and PPU I replaced with the machine socket, and with the round machine socket type. I did dual wipe here, and I did machine socket here. My OSD is going crazy over that. I had to fight my OSD because I like everything the same. But since this is one of my first boards, I wanted to see the difference of contact between the dual wipe and the machined. And since these PPUs and CPUs are kind of expensive and rare, I wanted these to have a good connection, a good home. And I really don't see any difference in these, but you have to be careful. Again, when you mate these, I bent this last pin 20, kind of bent up. So when you mate these into the machine sockets, you have to be really careful. Get all your pins straight and lined up. But that feels like a strong connection. And the dual wipe feels like a strong connection. I don't know. Maybe I'll just go dual wipe in the future. Or I think I've seen it done, or maybe make a socket for him. Maybe put the PPUs in a machine socket, leave that there permanent, and then put that whole thing into a dual wipe. So you're not mating and demating and stressing out the pins on your PPU and CPU. That'll mess them up. You don't want to break pins. If they break too close to the ceramic body, and then it's hard to solder and fix them. But all right, let's power on one more time. Let's power on, and let's do the sound check together. We'll play a little bit. We'll play a little bit here. Ooh, get that adjusted out so you can see. Okay, so what are we on here? All right, so let's do Mario. Let's do Mario. I have to do sound one at a time. Okay, see, Mario's looking pretty good. Okay, wish my camera would take better video of. Okay, so let's run with Mario. Can you guys hear that? Sounds pretty good. And the audio section got new capacitors too. Don't forget your extra guy. Bam. Bam, bam. Mario has to be one of the toughest characters in all of video gaming. He's been to Dinosaur Land. He could do some amazing stuff. Mario's pretty badass. And this is the game, one of the games that made him super famous. So it sounds great, looks great. I'm using this is why I made my homemade box connector like this, because I might not be able to play like a pro, but at least test the controls. Alright. We'll do... Oh! I was trying to get to the end. I was trying to show off. I'm going to start at the halfway point here, see if we can... I thought one of these was a star. Guess not. Maybe that's on the console version. Alright, see you Goopas later. So that's one thing about fixing the games. You should fix the games, but you should take time. You should take time to play the games. Okay, so let's switch to audio. Let's switch to audio on the PCB Junkie, that first jumper. All right. So let's go with some Excite Bike now. Okay, let's go with some... Oh, better go! We got good sound. Man, that video is just awful. There we go. Alright. So we have all of our sounds. Gameplay, controls, no freezing, no anything. I think this guy is good to go. We'll do one round here. I like both of these games. Excite Bike is a really great game. Just simplicity. Bam! Let's see, how did we qualify? Hey, first place, qualify. Okay. Yeah, what a good jingle for finishing this video up. Alright guys, I'm going to cut here. Let's get the next one on the bench and go from there. See you guys later.